He is presently working as Research Associate Professor and Research Vertical at School of Reva University, Bengaluru. And a design engineer from Webcos Limited, a central PSU under Ministry of Water Resources, Government of India. He has a vast experience in the field of quantum energy practices to power system optimization. He has a research experience of over 16 years and has sound knowledge in the field of sensors and quantum digital image processing. He has published more than 168 numbers of research papers, both in international journals and conferences, along with 3 granted patents. He has received 10 Professional Research Award by Science Engineering Research Board, Government of India, Madhusudan Memorial Award, Institution of Engineers India Young Engineers Award, and Green Energy Award by Reva. He has handled many research projects funded by DSCE, NRDC, IPR, taken 3 ongoing projects sanctioned under DSCE Hub, DSCE, NRDC, and Cradle, amounting to 4.97 crores. He has guided 7 PhD students and 6 students currently pursuing PhD under him. Now I request our HOD sir, Dr. Kumar sir, to hand over the sapling to our today's research person, Dr. Ritesh.
Take away, yeah.
Sir, that's it.
Now I request Dr. Ritesh to take over the sessions.
Good morning to all of you. Last time also we had a discussion, I think 4-5 months back. We had a discussion. So today I will be discussing something about the topic that sir has already given me. Now before starting anything, I wanted to hear from something, then I will start. Okay. So based on the FDP title, okay, I have some presentation, but before that I want to know, like what exactly you want, what is the problem? Then only I try to give the solution. What is the problem? you are facing related to the research activities, because this is mainly on the research, this is not very technical. Only on research I will be discussing. First, let me know like what is the problem that you are facing. Then I will start activity. That is what my understanding, because if I tell something that may not be relevant to your work, so there is no point of discussion. So if you can tell some points to me, like what exactly you want, then accordingly I will start.
So basically we are doing research, fine, we are having research. The thing is how to convert that into patent so that we can go till grant or commercialization. So that research, how to convert that basically into that. Main thing is.
Any other points? Just please keep on interacting with me so that I can understand the level. Accordingly, I will deliver so that at the end of the session something will get. Or else there is no point. If I simply read the PPT, there is no use at all. So if you can tell something what is the requirement, accordingly I will showcase our one point. That is really very good. I will cover that one, sir.
Yes.
Similarly, any other points? So to start with, first I will tell one thing. I will not start the PPT first. I will show you something so that I will address first start point, then I will come to the PPT section. Okay? Can you have some internet, sir? Yes.
If you want something
I have the say C sir. C
I'm addressing first.
So one more thing. So when they are doing the PV energy management and wind energy management, wind energy, they want to integrate into microgrids. That the irradiation, suppose no need to go there exact spot. I have collected from the Ministry of website and one more website. Like that, any other ways there to collect the wind speed, all those things.
So, the first point I'm addressing, sir, this is the project that we have developed under DSCE. Okay, the project was sanctioned in the year 2023. The project is about to complete in March 2026. Okay, so I am showing the point like what is the source, like how to convert the research into the patentable or the product domain. Okay, so DSCE will not give any fund if you simply write a project. They will not give. According to the DSCE criteria, the first criteria they will ask whether whatever project you are writing or submitting to us, whether it is TRL level 6 or not. They will first check that one whether it is TRL level 6 or not. Okay. TRL level, different TRL levels are there. TRL stands for Technology Readiness Level. TRL will start from 1, that is minimum is 1, maximum is 9. TRL 1 to TRL 9, right? TRL 1 is the concept like one hypothesis, one hypothesis you have. Like I have one circuit, it is working on Ohm's law, that is TRL level 1, that's it, okay? Now you have to go from TRL level 1 to TRL level 4 first. Okay, how to do that one? By doing or by developing some electrical circuit with your students in your lab. Okay, that is from TRL level 1 to TRL level 4. Once you reach TRL level 4, the DSCE will ask, if you go for presentation, they will ask what is the evidence that you have achieved TRL level 4. Okay, because without evidence, they will not verify that. Okay. For that one, you have to go for some third-party testing who will test your circuits or your prototype and will issue one certificate to you. That certificate will have some validity. Like this prototype has been developed on so and so date and it is for 1 year or 6 months. Okay. So with that one, you will touch TRL level 4. Okay. In India, there are some very good like TRL level testers are there. One is called TUV-SUD, top suit. TUV-SUD, top suit. This is world #1 company. If your model or prototype is validated by top suit, TUV-SUD, then throughout world everybody will accept. DSCE will also accept because going for some big funding agency, they will also accept that one, top suit. So first to develop a prototype and get it validated from the top suit. Top suit will charge some amount, so you need to pay that one, then there is no certificate. Okay. Top suit is not only for electrical devices, it is for all the engineering devices, starting from medical field to communication field, electrical field, whatever field, they will test. They have different testing centers throughout India, different testing agencies are there, they will do the testing. One testing center is there in Bengaluru also, actually 2 testing centers there in Bengaluru, where they are testing only the medical devices like all MRI scanners, they can test. Another branch is there near to the airport Dayananda, where they are testing only the communication devices. Similarly for electrical devices, Chennai they have one branch where you can test all the inverter, converter, whatever maybe you have, you can test it. Okay. So for this project, actually first you have developed the prototype in 2021. Then it has been validated through TopSuit in 2022, and finally the project proposal was submitted to the DSCE in 2022 March, right? So before that, what are the works that we have done? That first I will show you one by one, so that you will come to a stage to understand what exactly the work, what level of work you need to do. Okay. So this is the dashboard which has been developed for this project only.
This DSCE is a new one.
South Town.
This is the real-time model which is working now. Real-time, okay? You can see the timing and all. I'll show you. It is loading. This is the exact satellite image which is synchronized with the Indian Meteorological Department. Okay, so Indian Meteorological Department is also a co-PI for this project work, right? So directly we are taking from ISRO GSAT 4.6.1. This image is coming from that satellite. Computation has been done. Now to do this project, I'll show you. This is the this loading which is So now you can see the details of the part. This particular project is for the graveyard. Okay, so that's why it is showing grade 1, first one. Then it is showing Muniappa farm. Muniappa is the name of the landowner where the device is installed right now. That is what is showing Muniappa. Then it is showing that at the location Chikbalpur, Karnataka. Okay, so if you can see the detail, this is the dashboard. You can see from February 25 to June 10, 2025, it has captured the data. After that, it is not capturing the data. Okay, why it is not capturing? Because the project is about to close, so we have stopped that one. It is not capturing, but the device is working. Okay, data capturing is not happening. So what exactly we have done here? First is to do the project. We started the survey like door-to-door survey, door-to-door. In Chikbalpur, almost 11 villages door-to-door survey has been done. So door-to-door survey in the sense like the work is in 2020-21 January from that we visited almost 10 villages in Chikbalpur area that has been identified through some faculty. Where is the village map? We surveyed door-to-door in the sense first one is collecting how much land they are having, what type of crop they are doing, how many people are farmer in their family, how many number of males are there, how many number of females are there, children, activities, the source of income, everything has been collected. So like this, we have collected almost 6,000 data from the 10 villages, each, like every one data. Accordingly, you have to map that data with respect to their Aadhaar number. All these 6,000 data need to be submitted to the DST. DST will do random verification because for each person you need to provide the phone number. If the person age is below 6, then no need to take into consideration. Above 6, you need to take into consideration. So for each family members, we have to provide 3-4 phone numbers, and DST will do a thorough verification like whether you have visited to that place and you have taken the data or not. Like that, data has been collected first. After collecting the data, we need to understand where is the problem. Because some people may be in agriculture, some people may be into horticulture, some people may be into floriculture, like flowers also they have. So next target was how to identify the problem. Where is the problem? Okay. So when we approach the people over there, like this, we are from Reva University, we are doing a research survey over here to understand the problem. Most of the problem in Chikbalpur area, either they are working in the graveyard or they are working in the pomegranate. Either this or that. There is like no agriculture type of things, either horticulture in pomegranate or horticulture in the graveyard. Okay. So after discussing with many people, almost 80% of the farmers in those villages, they are having the graveyard. Okay. So graveyard only we targeted. So our target was the graveyard. Now in graveyard, what are the different problems associated with the grapes? Okay, if you have seen the grapes are having two main problems. Either you find some white color fungus on the grape, or you will find some black color fungus on the grape. Okay, either this or that. Either white color is there or black color is there. White color is called the white lilybug. Black color is called the black lilybug. That name is like that. White lilybug, black lilybug. White lilybug. The problem is, if the temperature of the environment is at 17 degrees centigrade with moisture, and repeating 17 degrees centigrade with moisture, then white lilybug will attack within 4 to 5 hours. If the temperature is around, let us say 20 to 23 degrees centigrade, moisture content is less, then black fungus will happen. These are the two problems. So our main target is to give a prediction system which can predict 24 hours ahead itself, like this will be going to the condition tomorrow, take some measurable action so that this white lilybug or black lilybug can be avoided. That is the problem. This is the problem formulation. Okay, problem is nothing like from the literature survey we have done or something, nothing. Problem is very simple. These are the two problems, either white lilybug or the black lilybug is the problem. How to provide a solution to that. That is the problem statement. Okay. Now, whether this problem statement is correct or not, who will validate that one? For validation, we approach JKVK. Okay. So when we approach JKVK Engineering College, Agricultural College, we have some contact with the professor. We approach JK sir. Survey has been conducted, and this is the problem that has been found. JKVK people, they arranged a meeting with their research team to discuss. So the discussion, while having discussion, they are telling, sir, this is not today's problem. This problem is there for last 100 years in Bangalore. But there is no such prototype or device as on today in Bangalore to protect this one. And our JKVK, they are only working into pesticide sprayer. They are not working into the domain of the technology development. So while having discussion like this, finally it has been decided that we are going for the one model prototype. Okay, where the objective is to do the forecasting. The objective is only to do the forecasting. Take the real-time parameters, do a complete forecasting for the work. Okay. Now, the thing is that if I directly write a proposal, project proposal like that, and it has submitted to DSCE will not approve, or any funding agency will not approve blindly. Okay. For that one, the next target is we approach NABARD Chikbalpur Center. So when we approach NABARD Chikbalpur Center, they have given their last 5-year agricultural yearbook, like only for Chikbalpur yearbook, where all statistical data they have there. And if NABARD is giving some book that is 100% authenticated, there is no doubt in it. If you refer any journal paper from very high impact factor also, there will be a doubt whether this paper has been written in so and so condition and it is applicable to Bangalore area or not. There is a question mark on it. But if you are getting any document from NABARD that to all parameters are clearly written, then there is no doubt in it. That is how we have taken NABARD into also confidence. Okay. So after taking NABARD into confidence, then who will fund first those prototype? Because DST will not fund for 1 lakh or 2 lakh. They are into huge funding agency. So to develop the prototype, then we approached NRDC. NRDC is National Research Development Corporation. NRDC, National Research Development Corporation. Okay. NRDC has two funding systems, either 2 lakh funding system or 5 lakh funding system. If you are developing some prototype with a student, you can ask for 2 lakh. Immediately they will give. 100% they will give. But if you are asking for 5 lakh budget, difficult to get from NRDC. For that, tier level 4 is required. But for 2 lakh budget, tier level 2 is also sufficient. They will release the fund. 2 lakh you will get to start the work. But NRDC is looking into one thing, that whatever funding they are giving you, you have to develop a valid prototype that you have to demonstrate it is working nicely, and finally you have to submit the entire test report to NRDC. Based on your test report, NRDC has its own team who will come to the field and do the verification, and they will issue the TRL level 4 certificate. Immediately within 1 or 2 months, certificate will come. TRL level 4 has been filed. Okay. With that TRL level 4, now if you go for patent, chances 85% chances are there you will get the template patent, because already you have TRL level 4. Okay, most of the patents, whatever things we are filing, either we are filing a design patent or you are filing a general patent. Okay, either this or that. Design patent, if you have, even if you have 100 design patent also, it carries 0 mark if you are going for any funding agency, because they will not look into design patent. Okay, they are looking into general patent where some numerical validation must be there. If you are writing some patent which is like only one diagram is there and some things you have written about that, if you are filing, chances are very rare that patent will get accepted, because there also you need to have a numerical validation. Okay, so for that one you need the TRL level 4 certificate. If you have that one, if you are attaching that one with form number 7 for the patent, chances are 85% chances are there patent will get accepted. Okay, so this is the procedure for patenting your research project. Okay, now there are 2 types of patent. I hope you know this concept. One is called concept patent, one is called general patent. Concept patent means, suppose you are working in some domain, something you are doing, let us say some converter you are designing and you found some novel things. Okay, immediately file the concept patent. Right, immediately file the concept patent. Okay, after that, once concept patent is done, that idea is now locked for you. Then you do some research, do some activity for 2 year 3 also, no problem, because already it is patented. So whatever result you will get with that prototype, now you go for the general patent. But your idea is protected. That is really very important. Okay, for this one I will tell you one small story. I hope you know. If you have seen the MacBook. In MacBook, always the advertisement will come like neural engine. MacBook will never write, they will never write like Intel or ARM processor or nothing like that. They simply write it is a neural engine. M1 model, M2 model, M3 model, M4 model, M4 neural engine. Okay. Now that neural concept, because of that, Intel and Apple they fought for 20 years, because the term neural, it is like developed by Apple only. Okay, neural term, because all the MacBooks are neural engines. They are not cerebral system, they are neural systems. So what happened? If you are getting some new things, immediately you try to patent it. Then go for all your research activities, whatever things you wanted to do. Now, in this project, what happened? When we have developed, because in this dashboard we have not developed for TRL level 4 or TRL level 6 development. Okay, it is not that. Only the hardware was developed and the hardware was validated. Right? Now, after developing the hardware, whether the result, whatever things you are getting, whether it is correct or not, who will give that certificate? Because this is related to some environment. Right? Environment in the sense what? We are capturing the wind velocity, we are capturing the solar intensity, we are capturing the environmental temperature, we are capturing the humidity. Okay, so core parameters we are capturing here to do the forecasting for a particular geographical area. Now for that one, who will do the certification? Because whatever wind velocity, all these things we are capturing, who will do certification? For that one, in entire India, only one agency, that is Indian Meteorological Department, IMD. If you approach in Bangalore also, IMD headquarter is there in Bangalore also. So if you are developing any prototype which is weather based, okay, like you are capturing solar intensity, anything, you have to approach the Indian Meteorological Department. They are charging some 24,000 to test it. Okay, so for that testing, they have their testing team. They will come from Chennai. They will come with their own instrument setup. Wherever you are installing your device, they will go there. They will test everything. They will calibrate that one, and finally they will give one certificate. Okay, that certificate validates that your data, whatever things you are capturing, it is up to the national level. Okay, that means what? That means they are giving one certificate to you. Whatever data you are getting, you can sell it to Indian Meteorological Department. You can sell your data because data are very precious. You can sell your data to IIT. That means IIT is ready to take your data. Clear? Similarly, in Bangalore, now IIT is having four observatory points where they are capturing the data, real-time data they are capturing, and the data what you are visualizing in the news channel or in the newspaper, it is coming from that observatory stations only. Okay, so like four are there in Bangalore, only from IIT. So this is the validation level. So to come to the level of getting approval from DST or SCI, first you have to do all this background activity for 2 to 3 years. Then only you will come to a position where you can apply to any funding agency. Okay. Now I will come to the funding part for this project. The funding was 57,66 rupees. 57 lakh 0.66 is the funding for this prototype. When we have done all the background research from getting some funding from this agency, that agency, we have done almost by that time we have spent around 7 to 8 lakhs. But when we approached DST for the funding, they have released this much amount of money for this prototype. Okay. Now this prototype has been handed over to a company called FYO. It is a Bangalore-based company where we have done the technology transfer. TTL has been done with that company. We sold this prototype at a cost of 3.7 crore. Okay, investment to us from DST is 57 lakhs. We sold this one at that much crore. Okay, so whenever you are doing TTL like technology transfer, we are doing to that company, whatever revenue will come, that is to the bidding option. That is the bidding it will go. Because all validation has been done, everything is done, finally it has been sold to the company. Okay. So whatever revenue will get, that will not come to you or to your institute, it will go to the government of India. Because this project is developed, funded by them, you are only an investigator of that. Okay, you are nothing at all. You are just an investigator, a scientist who has developed that, but finally the bidding action will be taken care by the commercial department of Karnataka. You can approach, they will do the bidding action. After all this validation. This is how you can take your small idea to that level. It took almost 9 years from idea to commercialization. This is just a pathway. Okay? So like this, another 3 is already going on, but I don't know whether it can be come to commercialized stage or not. But this is the procedure. Okay? Now I have just shown one idea how to commercialize your things. Now I will come to the electrical point. Okay? What are the scopes in electrical? This is related to this is not related to any electrical, this is multidisciplinary action. Your agriculture person is required, your electrical engineer is required, your communication system is required, your network engineer is required, cloud computer engineer is required, sensor technology is required, nano sensor is required. So almost 8 people were here to complete this one from scratch to the final. Okay? This is a multidisciplinary action. Right? Because if you are going for pure electrical based research, pure electrical like our electrical machines, converter, power system, all those things, there are crores of funding available. Crores of, but exact problem statement you need to frame. What is the problem? Okay? For getting any problem related to electrical engineering, I'll show you. You approach first either the Karnataka State Electricity Board, what is the problem they are facing, or you approach to the Power Grid of India, or like POSO, another name is POSO, you can approach them. Okay, thousands of problems are there, and it is geographic indicators, like different geographic areas there where they are facing the problem. Okay, I'll tell you one simple story. Have you heard the name called ANRF? National Research Fund. Okay, recently that changed to ANRF, right? Now, I hope you heard like the ANRF Anusandhan Fund. First time it was released last year during January to March. The call proposal was there. Okay. There were submitted some projects there under ANRF. The presentation was over on 7th February only for us, so we are waiting for the result. Now, what will happen there? I hope like Karnataka State Electricity Board, another electricity board is there in Gujarat, that is called Gujarat State Electricity Board. Okay. Have you ever heard the name called GIL, Grid Integration Laboratory? GIL, okay. Have you ever heard the term called digital twin?
Yes.
Digital twin, now it is putting things, digital twin, okay. GIL, Grid Integration Laboratory, is an entity of IIT Bombay. IIT Bombay, okay, they have GIL. If you search in Google, you will get GIL. GIL is the only institute in the entire India who are working for discounts. That is the only institute. Discounts they are working. They submitted one proposal to ANRF, okay. Now, whenever we are writing project proposal, we are thinking about ourselves, like I develop some small prototype or something for research and all. You see the magic part they have done. They have taken entire Gujarat State Electricity Board as a customer. Okay. In the project proposal, they have shown to Government of India like we are planning to develop the digital twin for the entire Gujarat State Electricity Board. Okay. Where we are fighting for lakhs, 50 lakhs, 70 lakhs project funding, they got 75 crore for 10 years. Over all funding over 75 crores for 10 years. That means 7.5 crores per year they have taken the funding for 10 years. Okay. So now you think research is going in which direction? We are struggling for getting 50 lakhs, 60 lakhs, 75 crore in one shot over for 10 years project. Now imagine how many number of JRF, SRF, PhD students will work with them. Almost near about 100 people will work now. Like PhD scholars will be there because they will be deputing some people in Gujarat itself who will work with Gujarat State people. They will be having some liaison officers who will be working with the government, state government, many things. So almost now 100 people they will recruit for 10 years. This is the magic here. Okay. This is the level of research, right? Another research you see for this Indian Meteorological Department, IMD. Okay. IMD wanted to design one satellite which will work only for Indian meteorological system. Only. Okay. So for that one bidding happened. Two institutes came for the bidding. One is IIT Delhi, one is IIT Bombay. Okay. IIT Bombay finally got the bidding. Total bidding cost is 500 crore. 500 crore one project. That means you imagine the level of expansion, how many number of people will get involved, the scope of level of research, everything you can imagine. Okay. So if you think in that direction, then definitely project will come. Okay. Now, for that one, let us see how so for that one, let us see what are the problems in electrical engineering, how you can work. I will show you some real-time statistics of India. See, I discussed only from the electrical point of view, that is power system. Okay, because I am basically from NHPC, so NHPC means we deal with the power systems only. Okay, we are not much bothered about power requirements. So if you see the Indian statistics, India has 5 different regional electrical headquarters. 5, total 5. One is southern part means all Karnataka, Chennai, Andhra Pradesh will cover. Then like northern part, southern and northern. Then eastern part, northeast part, one is central zone. Total 5 zones are there. Okay, 5 zones. Now for this 5 zone, what is the major problem as of today? I hope you heard the term called LVRT.
Yes.
LVRT, low voltage right. Okay. This LVRT term, when we were students like 15 years back or 10 years back or 20 years back, whether we heard LVRT term, it was not there. LVRT came into picture on 31st December 2017. It came into picture first time. Okay. Why it happened? Because 2027 December midnight 11:55 we convert, like we merged all these 5 regional grids into one grid, like one grid, one frequency happened first time. So now throughout India frequency is same, 50 Hz everywhere. But before that it was not there. Every regional system is having their own different frequency, like 49.96 or 50.03 like that it was there, but after that it is now moved to 150. Clear? Now, what is this LVRT term from where it came? Basically, LVRT is related to renewable sources like wind or solar. Okay, for general like conventional synchronous motors and all, it will not come into picture. Okay. Now see the magic. If you want to push the power, from inverter to the grid, how to push the power? Like I have my solar plant on my rooftop plant I wanted to sell the power to the grid. How I do? The controller will be there, everything is there. Now finally I am getting inverter. Then DC I need to convert to AC. I need an inverter. Inverter is also there. Now if I plug this one to the grid, like to the substation and anything, whether I can able to pump the power? Power cannot be pumped. Okay? Even if you simply connect to the grid also, you cannot pump the power from your system. Okay? Why? Because according to my theory, I know that inverter cannot produce reactive power. According to the theory. Okay? But I know that without reactive power, real power cannot flow. That is also there. Now if you have inverter and you are connected to the grid, so whether you can pump the power cannot be. Okay? So for that one, you need some amount of reactive power at the point of inverter. Okay? Now, like your desktop or laptop, you have something called booting sequence. Like if you turn on the laptop or desktop, it will take 1 minute for booting. Okay? Similarly, if you have the inverter, let us say 1 kilowatt inverter, let us say 1 kilowatt. Inverter has its own booting power. Like if you are having 1 kilowatt of inverter, then booting will be 1.25 times. That means inverter will throw immediately. If you turn on the switch, like even in your home also UPS, if you turn on 1.25 times extra it will throw. So what will happen if your voltage is 400, because when we are doing MATLAB simulation or something, we are only thinking voltage needs to be balanced, like 400, 300, something and I'm not thinking about other parameters. Other parameters actually play the important role. If you are maintaining voltage 400, according to the concept, if you switch on the inverter will throw 1.25 times. So 400 volt will become around 400 or 500 will touch immediately. Fraction of second 500 will touch immediately because of the condition. Now within that time, if you are doing synchronization cannot happen. It cannot happen. Okay. Now why I am increasing the voltage? Because I know that reactive power is associated with voltage. Okay, so if I suddenly increase the voltage to a high level, then only reactive power will come into picture immediately. That is the concept. Okay, so only we are doing this one, right? That's why if you see any big research articles published in some very high impacted journal, if you see the grid synchronization voltage, they will not maintain 400 volt at the terminal of the inverter. They will maintain some 360, 365. There is a gap of 40 volts. Okay, but when we are thinking about our own research in MATLAB, we are only looking into 400 actually match. No, it has to be 360 or 340. If you keep it in that band, automatically during turning on it will latch to forward. Automatically it will happen. Because of that one only, LVRT come into picture. Because after today also, to do the synchronization in real time, we require minimum 7 cycles. Minimum 7 cycles, that means 0.14 second is required to synchronize 7 cycles. Throughout the world, the research is going on how to minimize this 7 cycles to at least 6 cycles also. Let it be 1 cycle you can able to cut also. That is a very good research. Okay, so this is one point of research you can find, or you can do some research activity. How to bring down this one into 6 cycles. This is one thing. Okay, so you can work on it. Another point you see, the major power system, only I am discussing about power system, no probabilities. Another event you see. Now, I hope already all of you might have heard about the power system protection systems or reliance numerical units you have, right? Now, can you tell me how much time it is required to decide whether this is a fault or not? Power cycles are there. So how much time it is required to decide whether this is a fault or not. Any milliseconds, right? So, according to our theory or whatever we have at present also, minimum to minimum I would require 1.5 cycle, 1 full cycle or 1.5 cycle. So 0. You can say 0 to 0.5 level. That much amount is required to take a decision that it is a fault. Now, with that one also, because 0.0 to 0.5 also very high time. If you are talking about current in amperes, not ampere, kiloampere level, so 0.0 to 0.5 also will create huge amount of loss. So now people are working how to reduce it to 1 cycle or even half cycle. That means within 0.005, if you can able to predict that this is a fault, then definitely your research is much more better than any other research. Because throughout whatever switchgear protections are available, minimum to minimum 1.5 cycle is required to take a decision whether this is a fault or not. But if you can predict that one within half cycle, then this is a novel work. Okay, that's why your typhoon, gale, your D-space, all these things are now coming into picture to do that test. Because I cannot manufacture one relay to go for a real time test. I can do it in HIL, typhoon, all those things I can do. D-space I can do. I can check whether my developed algorithm is able to perform a test or not. Okay. Now, second point. Next point is, I hope you heard the term called DWT analysis, discrete wavelet. Discrete wavelet transform, or FFT analysis, Fourier transform, right? Fourier transform is DWT, it is nothing, just a double derivative of FFT is DWT. Just that's it, that is the main logic. DWT is double derivative of FFT. Okay? If you take triple derivative of DWT, it will become HHT, inverse point transform, right? So now what is happening? We are now not into the cycle level analysis. We are now thinking energy level analysis, not cycle. Because cycle, okay, 1.5 cycle I have to go. Why? Because for any protection system, I need to find out where is the 0%. Because I need the reference to calculate 0 to 360 means or 0 to 180 means 0% will come. Then only I can identify which cycle is getting over. Half cycle if you are going for, I cannot, the sample and hold circuit or the PLL circuit, it is not able to find out where is the 0%. What is the reference, where is the 0%, it cannot be able to find out. That is the limitation of the research. There is no particular mathematical evidence where we can find geodetection without SIH or PLL control. That is the limitation as and today. So if you can do something, it will be better. Now, instead of that, let us do the analysis in terms of energy content. Whenever there is a fault, one arc will come into picture. If I can able to capture that energy content of that arc, then I can do a better prediction system. Based on that only, your HHT technique came into picture. Hilbert curve transform. In Hilbert curve transform, main objective to capture how much energy is there at that fault point. So based on that, whatever calculation we will do, that is also Nobel. Okay. So these are just the 3 different things I have told. What is the problem now we are facing? As of today also, this is a problem. Clear? Next, this is the original data that I have captured from different ministry. If you see here, the first point, okay, these are the general things. If you search in any Google, you will come to these are general points. Okay, what is the main point? You see here. There is something called AT and C loss. In transmission distribution system, we have something called AT and C loss, aggregate transmission and cost loss. Okay, what is that one? Starting from the point of generation to the point of utilization, how much revenue we are losing. It may be transformer, circuit breaker, whatever may be. That is the AT and C loss. Okay. Up to 2020, this AT and C loss was almost 21% throughout India, almost 21% loss. Okay. Now, because of PFC, I hope you heard PFC, power factor correctors like some statcoms and all those things we are doing. Now, StatCom has its own limitation. Even if you are connecting the StatCom, it has its own limitation. Okay. So what we are doing, even if today you go to any substation, you will never find any PFC or power factor correction. Only you will find the capacitor bank. Today also capacitor bank in almost all the substations, capacitor banks are there. We are never going for any flex devices, okay? Why? Because you see the problem. There are two types of substation. One is called switching substation, one is called distribution substation, okay? Mostly the power factor problem will come in switching substations. Switching substation means, let us say outside Bangalore, you have one substation where I am diverting the supply because Bangalore has 4 different zones for distribution section. So there I am splitting the power into 4 different zones. Okay. Whenever there is a demand in one section, immediately I divert the power. That is the main objective of switching substation. So in switching substation, always the problem will happen with respect to the power factor. Because I cannot balance all the feeders at a time. In one feeder there may be huge power, in another feeder there may be less power, or the less demand will be there. So I cannot balance it. So always there is a problem with respect to the switching system, switching station related to the power factor. So if you can come up with some idea to handle this situation, then definitely you will get the funding from government, 100%. If you can come up with some logic or something like that, 100% you can. But don't go for the conventional STATCOM or PAX devices. It is because actually not very negative, but other things they have done in that book of the research. It is related to the theory concept. But when it comes to the practical, its application is very, very limited. Even if you connect also, you cannot find any effect. Okay, it is like a IEEE, like 11 bus system or 13 bus system. If you are working, you do whatever faults. You cannot visualize any effect in the voltage or current. It will not come because the system is highly stable. In 13 bus system, if you are taking 2 generator bus and 1 slab bus, then effect cannot be visualized. You have to go for minimum 33 bus, 66 bus. Then only okay. If you are getting fault at the trailing end, you may get some variations, or else you will not get. So these are the certain limitations in the power systems where the research is required. I think it is required. Clear? Now how to do this research? So what we have done? Now according to the ministry, if you see the Ministry of Power, we are facing one problem related to the transformer. Okay, transformer, whatever things we are teaching in the classroom, like transformer is a bidirectional device. Okay, you can transfer from primary to secondary or secondary to primary. Okay, actually, if you see the book, some book, author book, furniture book, they will never write primary, secondary. They will write LV side, HV side. Power can be transferred from LV to HV, HV to LV. That is with respect to theory. Okay. Now, if I give one transformer, always whenever we are connecting the supply, we are connecting the supply to the input side, or LV side or HV side, and we are taking the output. Now you rotate the same transformer and you give input to the output side. You give input from the output side and take from the input side. Whether transformer will work with it. Transformer will not work. Okay. Why? Because in transformers there is something called short circuit capability. If you are taking one transformer 1 MVA capacity and if you are reversing the transformer terminals, okay, for any operation, then transformer can handle a capacity up to 17% of its full load capacity. Suppose transformer is designed for 1 MVA. If you have reversed the transformer terminals, then transformer can handle up to 17 kilowatt or 17 kilowatt. It cannot handle the 1 MVA. That is the problem with the transformer. Till today also that is the problem. Why it is happening? Because LV winding will be inside, HV winding will be the outside. If you reverse the supply, what will happen? Your input will come to the output side, like outer layer, and your output is the middle layer. Okay, so the induction effect will radiate to the outside. It will not radiate, it will not loss for the low voltage winding. That's why that is infiltrated. That is called the short circuit capability of the transformer. If you can come up with any such devices which can avoid this type of things, then this is a novel system. Because that is the limitation of transformer. I cannot do whatever you do, just make the transformer to be up to the full load capacity. That is the limitation of the research. So if you can come up with some winding changes or something where you can do this one, then that is the novel research. This is the research. Many problems are there in power system like this. Thousands of problems. Problems is everywhere. Okay. I will tell you another small problem. I hope everybody knows this one. This transformer, whatever things we are teaching in the classroom, we are telling like transformer cooling methods, like we are telling oil natural, air flow, oil flow, all those things are there. This concept is not applicable for hydropower plant. Okay, this oil-based transformer is not applicable for hydropower plant because transformer what we are teaching, it is called general purpose transformer, like power transformer or distribution transformer. Okay, but the transformer what we are using in the generating station, whether it is thermal or hydel, that is called generator transformer. Generator transformer construction is completely different. Okay, different in the sense what? In generator, voltage is not constant. If water is full pressure is there in the water, voltage will either you will be getting at 13.2 or you will be getting at 17.6 as and today. In hydel you cannot achieve 22.2 generation system. Only in thermal you can achieve 22.2 kilowatt. Maximum you can touch either 11.2 or 13.6. In the rare cases, 17.8 you can touch the kilowatt output. So transformer will always experience a variation in the voltage at the input side. 16.5, 17.2, it will keep on changing. It is not constant. But whatever transformer we are using in our day-to-day life, for that transformer input is always constant. Voltage is always constant. Voltage is not fluctuating. But for generator transformer, the input voltage will always fluctuate. Always. So if we are putting this oil natural, air natural system or oil blast system of cooling, the transformer will turn on. Okay, for that one, if you see any generating transformer, instead of oil, we are putting water drops around the transformer. The cooling system is water drops. Okay, continuously the water will rotate inside the transformer. Okay, but that transformer is so designed that water will not touch the core. Water will not touch the core. Water is only a cooling agent. Continuously it is rotating so that the temperature can be come down because the fluctuation is very high. Input temperature is very high. Okay. Now there is a thumb rule for the transformer. Thumb rule in the sense whether to go for auto transformer or power transformer, like two-winding transformer or auto transformer. How to decide? Okay. Remember, if our voltage ratio is more than 2, go for auto transformer. Power transformer is not good. Auto transformer is not good. Okay. Voltage ratio more than 2 means 66 by 11 kV or 33 by 11. Like that, if it is coming, go for auto transformer. Or else, if you are making voltage step like 440 or 400 volt to let us say 11, then 2 wire transformer is sufficient. But if you are getting more than 2, actually it is 2.5, but nowadays we are working with 2 also. Then go for auto transformer or else go for the general transformer. So can you come up with some device which can maintain the input voltage constant for the transformer? Then definitely we can save, like this ATM seal or what I am discussing now, we can reduce it to even less than 11 or 12. That much requirement is there in the research. So this is the research area actually. The problem statement is this one only. If you go to any power grid, these are the problem statements. If you can provide some solution to them, they will be very happy. This is the problem. Okay. Similarly,
We break the meeting for 10 minutes. Please all of you resume back.
See, I am not discussing anything related to PPT because you can find all those things in internet also, in books also. I am discussing those quantities which you will not get in internet. What is the real problem statement? How to address that one? Okay.
To reach to this
You can send official paper from the college or or it should to the board of electricity board. They will have a meeting. They are attending. You
And especially only research is very times. Last year also the same kind of case. Bring them money. If they are relevant, just bring them to find it. Just tell them very clearly they are not belonging to the city. The lecture side of that and our process of rights, we don't want this kind of just also for the back side. We should not take, if we do this, the same thing in the research, the same thing in the
So next day you find them.
we have to take very strict action.
So this day we
I don't know what we discuss, take strict action. This will be done. It has to be to give So you ask them, I don't know what people they come for any kind of excuse, fine. Don't send them to the
So these things.
people who are coming.
Another session is the one.
See, they come for any kind of excuse. Don't sign and don't send me an email, don't say you are not your choice. No. Go means no, that's it. You leave that. Don't give any excuses for these students. Whatever they come, you say no. Then the faculty gives instructions, if they are not ready to follow, why we have to accept their excuse? We don't accept their excuse. So take this strict action, otherwise these people will have this, and their placements will be much difficult back then. If we don't take actions now, you know how the current finds this crazy problem. Placements are very poor. And the same thing will be repeated for this batch. If they are doing like this, they have to be skilled, others will be a business problem. So take action. I want actions. Sending message all fine, it's fine with us. You are conveying the information is okay, but I want you people to take action, and that should be corrected in. So that should not impact other section and also the juniors.
They're all hundreds of what action we take it as a.
But when you study engineering, how you are
So okay.
it's our duty to keep them like that.
Whereas generation is different.
Well, generation different, all these things are fine. It's again in our hand. How we handle them, just tell them, you see, that is a way to tell. Just tell them very clearly, okay, you don't want to attend, no? Write a letter stating that I don't want to have any kind of training. Take sign from your parent and let your parent accept this. Then we will see. See, without that, if we shout, then as you said, the diagrams, all those things will come out. You say it this way, obviously they'll come back. So you take action, you know how you people take action. All 3 plus 1, 4 faculty are there for your class. So take action. So no one, we are paying huge amount for the trainers. For even student attends or they are not attending, we are paying money for them. It should not go waste. So instead, I cut that 10, 20 next time. That amount I can use it for some others who are good. Why they raise that money? That's my intention. Just inform them. Yeah. No, madam.
Saturday.
Everyone should take us permission.
Yes.
Ask them to write a letter, attach that hall ticket. Yeah. Those, once if I say permitted, then you can take.
Because STP students are also having exam. Some of them came and asked me to
STP?
skill development. Those who are having skill development on Saturday.
Yeah.
They have gate exam also.
Well, then if that is the case, why they could able to join with 7
I told them we can change.
Yeah, that's why. They can join with A section.
But they will ask if they are very much considered for regular lab or classes for distance. Like that also there is.
They can try to escape, but they should put some boundaries then and then only they will not go out. So once I permit, then we can say okay to
These are the intentions to this.
it.
Always was fine.
It is for second day or
Today for
Today you missed that day or something. I'm being student result for the next results. Okay. So that is the big result.
4 and 6 are important for instructors.
So you also say. So there, how much workload they give for you? So you are into the research side, right? They give academic loads also.
Sir, academic load like only 2 labs I have.
Okay, labs.
One for engineering, weekly 2 days. 2 days for engineering.
6-8 hours.
Remaining time for this work.
Yeah, obviously, otherwise we cannot do. Because when the designations for the research, actually speak, they should not give any uploads.
But every department there are one or 2 research partners. First then, whatever it is, first then they target. Now we are also doing consultancy. Consultancy, we are working on 2 maintenance work, one for sniper, one for dosing. So for sniper, it is like testing. For dosing,
What testing?
so testing is the same like suppose we are developing one product. So for them, we are the technical consultant. So for anything related to the power system, we need to know control part and the so for that one also following that consultants are the corporate engineers. So they are very scientific, they are people to also there will be 6 hours every day and then only on transport.
How you will be doing? Science and engineering.
Saturday 6 hours for that. So there is only on transport. It should be 5 hours. Cover for student charging
Okay.
after also the same certification
So that when you go to the institution, some new sharing, no, then why you are doing classes?
research purpose.
So why science?
Because those people they are
is fine, because that is the company restriction. Here we can have.
Here what Sunday, then I will get one compost.
On Sundays only.
First and third is
Second, fourth, and 5 also. And Brookfield, what happened?
Brookfield, actually Brookfield is nothing on taking Apollo Hospital. For them, they have taken maintenance of all other hospitals in India. So we are providing training of their maintenance system. They are training to the hospital.
So only you are doing, or other people?
Especially for Brookfield, so like that.
How many in the department only for research question?
Every department to expand it.
Yeah.
Now they're expanding. Only
Projects. Revenue and also for electrical consultancy, yeah, difficult. Here, if you see civil, they do very big consultancy. We cannot compare much crores they are getting. Yeah. But people in this getting thousands itself is a very big question. Yes, correct. They do the CPRI testing, when we ask, okay, can we do delay, it's what we are doing this. What is that They do a lot of trainings nowadays. At least monthly once the people come here to give that brochures.
They also know very
Even now the batteries also in batteries.
So for that one, they are now
उसको बोलिए पेमेंट नहीं किया हुआ
Every time they ask
बाय मिस्टेक नहीं हुआ
licenses required expertise, expertise also. Even if you want to do the auditing, you don't just have to do the auditing course and just complete that
like AMI engineers.
So for all the research purposes, we already set 5 But project proposals we can submit, it's not in our hand as usual. Whatever the efforts we can take, and everything we will take. Yeah. That part to private institutions was
once
all of you come
so
now.
the London private university.
That's what I'm facing now. On the agencies, that's like what I'm running to analyzation. We have to manage so many people.
Seven JRs for 2 JRs, they have not received the help of
Both the same. Both the same.
Maybe it is that salary. Every 15 years,
Yes, sir. 3 years I'm working here.
That is institute can support.
Now next thing is why this reform is happening in the power sector. That is the now next point. The thing is that the first point that I have written, financial stress on the discounts. Before 15 years, if you say 15-20 years, it was under the Karnataka State Electricity Board. Similarly, for all the states, they are having their own board. They find that the total loss that is occurring in the system under AT&C loss is about 30%. 30% revenue generation is straightforward loss. Okay. Now, this AT&C loss, what does it mean? Okay, it is a very big story actually. You try to understand the situation. According to the Indian Electricity Act 2003, one rule they have come. The rule is like this: the frequency that we set for India, it is 50 Hz. According to our book, the plus minus 5% is allowed. Now it is reduced to plus minus 3 according to book. In 2003 Indian Electricity Act, they come up with 1.5 plus minus 1.5%. Okay, that means what? If the frequency is 50 Hz, then upper limit will be 49.95 to 50.05. That is the target. What happened before 2003? Suppose let us say in Karnataka I have 5 generating stations. Hydro is there, thermal is there, nuclear is there, everything is there. All the companies, they are selling their power to the Karnataka State Electricity Board. Okay. Frequency set is 50 Hz. Now suppose one generator, some fault occur, frequency changed to 49.93. Okay. That means what? The generator is pumping power to the grid. But as the generator has maintained a frequency of 49.93, so for that timing, whatever power they are selling to the grid, they will not get the revenue. Understand the situation? Situation is whatever power I am selling to the grid at frequency of 49.93, for that power I will not get the revenue. That is free power. But government will sell that free power to the customer at the same price. Price they are not changing. That means it is a revenue for the government, but it is a revenue loss for the generating station. Okay. So in 2003, all these generating companies throughout the India, they filed a case to the Supreme Court, like this is the situation happening, we need a solution for this one, we are not getting our power. After hearing for 6 and 7 months, finally Supreme Court decided that this current and frequency is beyond our limitation. Case has been transferred to Central Electricity Authority. Finally, Central Electricity Authority, one person is there, that is Ombudsman, like Chief Justice of India. He is the Chief Justice for all electrical related matters. He like the bench, they came up with a verdict, like all the generators that will maintain the same frequency. If you are selling any power apart from that one, then for that power you will not get revenue. That is final. So what happened? All the generating stations, they decided will not sell the power to the government, because it is the government who has to look into the system. So from that day onwards, DISCOMs come into picture first time. In 2003-2002 area, at that time DISCOM came into picture. The first state who imposed this DISCOM activity is Odisha state in India, and it failed. Literally it failed, because Reliance took over all the DISCOMs, it failed. Okay. So what happened because of that, the revenue loss, what is the AT&C loss was there up to 30% with the government entity, it increased up to 49%, like 50% now loss. Okay. So to reduce that one, they started distributed generation system. That means DISCOM has been divided into different zones. Zone 1, Zone 2, Zone 3, Zone 4 and divided. So after dividing all those things, this revenue loss has come down from 49% to 22% up to 2018. After 2018, again it has substantially reduced to now it is 17% in India if you see the total AT&C loss throughout India. Now the research gap here is, can you come up with certain algorithm which can further reduce it from 17% to let us say 1% also reduction. 1% reduction revenue generation will be around 30 crore to 40 crores. 1% reduction. So can you come up with even more than that? If you come up with some algorithm which can even reduce it further by 1%, then that is the very good research. And that algorithm can be patented. But unfortunately in India you cannot file any software patent. In India you cannot file any software patent, that is not there. You can patent the algorithm, but software cannot be patented in India. You can be able to go for some other country. So this is the research gap with respect to the AT&C losses. So if you can work, if you are a PhD scholar or something, if you can work on it, then definitely there will be a scope. Second point is rising electricity demand. The third point that I will tell, electricity demand. Okay. According to our calculation of the forecasting, by 2030, I think somewhere I have written 2030, India requires almost extra 500 gigawatt of electricity extra. Now from where it is coming? It is not coming from the population size. With the population size will not go in that order. It is coming from the data centers. Now almost all the software companies, they are installing the data centers throughout the India. Data centers, okay? In data centers, they require different power supply for different floor and even different node also. So maintaining to that level is a very critical challenge in India. Very critical challenge because you require power, okay, I give you power, but you want power in different level in different floor. That is really challenging system. So how to balance this one? In technical term, if you have seen the research article, it is called congestion analysis. Congestion analysis. Power is there, but I cannot pump. Power is available, but constant is there at the distributor side or at the consumer side. I have the power, but I cannot supply you because you have the constant. That is the congestion analysis. Like generation is available, but the load is not enough to take the power because I can supply power, but you want different power, different level. That is the problem. That is the congestion analysis. Many research are happening throughout the India or throughout the globe only on the congestion analysis. Okay. So if you are thinking for any research, start working for data centers. Only for data centers. Take the data centers as your prototype and think in that direction. Definitely funding opportunities there. And funding is not only with the DST. Funding is available for electrical. With CPRI also funding is there. Just now we are discussing this around. With CPRI also funding is there. Up to 20 lakhs you can approach for CPRI. Maximum you can approach CPRI 20 lakhs under RSOP scheme. RSOP, research scheme for professionals, like that something. RSOP, 20 lakhs you can approach if you are working on data centers. Similarly, if your model is related to like distribution side or transmission side, let us say transmission side, you can directly approach to the Power Grid of India. PGCIL, you can directly approach. Okay, this is the things we want to develop prototype. If the model has some novelty, something is there, even 0.5 also reduction, they invest. 0.5 reduction. We are not asking for huge difference. 0.5. If you can show your algorithm prototype, they are ready to invest. Okay, and with PGCIL at the initial stage, you can go up to 10 lakhs. Prototype, if you are developing something, 10 lakhs they will disburse. But if you are developing for large scale production or something, you can go up to 50 lakhs budget. You can ask for, but depending on the project strength. So this is another gap for the data centers where we can look into for the prototype or for the funding opportunity. Last one, something I have written called climate commitment. Okay, now climate commitment, this point was not there up to 2020. Nobody is looking into that domain. Now everywhere people are looking into that domain because now solar and the wind, that people are going in large scale like implementation. Everywhere people are talking about solar and wind. But whether in India we are really capable enough to pump the power from a rooftop solar power plant to the grid, the answer is no. We are not capable enough. Why? Because whatever power we are generating through our rooftop power plant, that is single phase. Synchronizing single phase power with a 3-phase system, there is no technique at all. Okay, something is there that is tri-vector meter. One device is there that is tri-vector meter. Through that one, artificially I am creating one reference to inject the single phase power to a 3-phase system. Right? That is there, tri-vector meter is there to inject. But that is not for every situation. Every situation means what? That is also another interesting story. You imagine, suppose let us say this is my home, I have my own rooftop solar power plant and nearby my home, like some distribution line is there. I cannot directly terminate my power by simply putting one rope or line to the line. Like how we are getting power to our home, like some tower is there, directly they will tap and they will give you single phase, triple, different requirement. But like that, I cannot tap the solar power directly to the system. That is the limitation. Why that limitation is, you see. According to the theory or MATLAB simulation, we can connect solar power anywhere in the simulation pattern. Just connect and we can put on voltmeter on something to see, okay, voltage is there, current is there, frequency is there. Practically not at all feasible. Okay, why not visible, you see. We are not considering the transformer. Where is the transformer in the line? Okay. For any substation in India, whatever substation are there, definitely there will be 2 to 3 outgoing feeder. Outgoing feeder means we are supplying to different zones from any substations. Okay. In that substation, there may be one transformer. Like power will come from transformer to one bus. From the bus bar, we will create the different distributors. like that. The system is like reading distributor or ideal, whatever it is. Now, to pump the power from the solar photovoltaic system to the grid, you need to identify the feeder first, in which feeder highest loading is there, because all the feeders are not balanced. Suppose this is one bus bar. For this bus bar, let us say I have 4 feeders. Okay, the transformer capacity, let us say 100 MVA capacity. That means all feeder must be equal to 100 MVA. That is the usual calculation. So let us say 4 feeders are there. One feeder is 30 MVA loaded. Second feeder, let us say 20 MVA loaded. Third feeder, let us say 25. Fourth, let us say 25. Total of 100. You cannot terminate your solar power to the 25 MVA system. You cannot. You have to identify what is the highest outgoing feeder. Always, any renewable sources has to terminate at the transformer secondary side, that to the highest outgoing feeder. Any feeder you cannot terminate. Why? Suppose you terminate to the lower feeder. What will happen? Suppose some breakdown occur, relay is tripped, immediately the backfiring will occur. The person who is working in the solar photovoltaic, either he may get shock or something will happen. So always try to terminate in the highest outgoing feeder. So if you are doing any research, identify first what is the transformer secondary. You should not terminate the power at the transformer primary side. Okay? Because some concept or logic is there. Why I am terminating in the secondary side? Concept is there. So identify the highest outgoing feeder, terminate there. Now the research gap is why always I want the highest outgoing feeder. Can I come up with some device or some logic where I can terminate to any of the feeder? Because that is a limitation. I have to terminate at the highest outgoing feeder. But can I come up with some device or some logic where I can terminate at the lowest outgoing feeder also, or any of the feeder which is nearer to me? Then definitely we will do research and it can be patentable. We will also fund it. In that way, you have to think. These are the problem statement, how to work on it. Now, for that one, whether if you can develop some logic or some transformer configuration, if you can change where you can manage this one, then government will fund it. Okay. Now, another research here, the research gap is like this. If you are thinking of any transformer primary side is basically it is delta connected, secondary side it is the star connected, that is delta star configuration usually. Now why we are putting in delta star configuration? Because to try the third harmonic, or the third harmonic will come in the secondary side, because of that one third we are putting it. Now instead of putting in delta for delta star configuration also, in some situations are there where 2 transformer is required, because I cannot convert direct delta to delta or delta to star. Suppose you want a distribution section, distribution transformer, then first you have to step down from delta to delta, then delta to star. So 2 transformer is required in cascade effect. So can you come up with certain things where instead of 2 transformer you can go for 1 transformer? So because of that one only now solid state transformers are coming into picture, so that we can avoid that one. That harmonics concept we can avoid, and all those things can be avoided. But solid state transformer has its also own limitations are there because of the heating effect and all. So if you can think in that direction, that is also another very good research area where project proposals can be written. Okay. Okay. Now, what is the data in the energy? This is the research topic. Now, the first one is the 20 crore smart meter has been sanctioned in the financial year 2025-26. 20 crores. Okay. First state to implement this one is West Bengal. Already trial run has been completed and it is working perfectly. It is working perfectly, trial run completed. The biggest challenge in the smart meter is how to monitor the data. So that's why the data center is now required for all the discoms, not only the software company, for all discoms also now data center is required to monitor these activities. Okay. For this one, that SCADA or the concept, whatever things we have learned 20 years back, now that is obsolete. Because SCADA will not work here. Okay. SCADA is for the substation monitoring, like substation operation, not for substation data analysis. Okay. For that one, new terminology has come into picture, that is called RTU, remote terminal unit. Okay. Remote terminal unit, one remote terminal unit can handle at a time 7 substations. One small computer can handle 7 substations at a time. Okay. That means what? The center of the RTU has to be synchronized with respect to how much power I am sending from my transformer terminal and how much power all the subscribers they are receiving at their terminal, that has to be monitored. So you can think of the data size and the volume of the work. Okay. So if you are good at data science related activities, how to monitor, how to balance all these things, then definitely there is a huge job market which is coming up within 2 to 3 years, not even 10 years you have to wait. Within 2 to 3 years, it is coming up in India where thousands of electrical engineers are required only for the data centers to operate this one. Okay, and RTO, it is now monopoly in the market. Only IBM is the company as of today in India who is manufacturing RTO, because RTO will work on Windows 97. Windows 97, not Windows 11, and 97 version only RTO will work. That is completely a C has programming, so Windows 97 it will work. So now whether we have engineers who can work on Windows 97, rarely we will find who can work on Windows 97 nowadays. Okay, rarely, because now getting people working in C programming is also very difficult. They are not getting people also. So that is the demand which is coming within 2 to 3 years, because already the procurement is going on, and you will find smart meters in your home also within 1 or 2 years, because already survey has been completed. I don't know in Karnataka whether it is done or not, but in Odisha, Chhattisgarh and all those states, survey is completed to install the smart meters everywhere. Okay. Now, whatever smart meters that we are understanding from our concept, like it will be like top up will be there, people will recharge, all those things. No, it is not like that. Okay, top up concept still now government is not taking any action on that, because if you power cut will happen like this, means half of the India will wipe off within 1 minute. Okay, so government is deciding we will go for trial version for 2 years to check whether data is free flow, it is coming to the centers or not, whether I am able to generate the bills from the remote end or not. All those things will go on now for 2 years. After that, they may come up with data. Okay, but for that smart meter, you need to pay. Okay, government will give you meter, but the customer has to pay 3,300. It is 3,300. Everyone has to pay. In Odisha already they have taken 3,003 rupees from everyone. They have taken. Say they will not directly ask you to pay. In your bill only it will come.
Monthly they are
Charging some amount, it will come extra amount. You have to pay. That you have to install. So now you can imagine the volume of work and the research in terms of data centers. Now we are for any PhD related work. Now we are searching for data, where to get data. Now data is coming to your doorstep only. You get all your data on your phone only, your monthly loading pattern, how you are utilizing it. Everything will now come into picture. So that is the biggest research area now throughout the India. Most of the IITs now only working on this one. If you see the professor's profile in any of the IIT platforms, either they will be working on the smart meters or the protection devices. Maximum people, because now this is the focus point, because government is interested in this one. So if you are developing or writing some proposal in this area, chances are more to get the project clear. So this is the things that we need to think about. Now, India has a target of 500 gigawatt renewable sources by 2027. But by 2026 January only we achieved up to 470. Another 30 gigawatt, it is just a matter of 3 to 4 months to get 500 gigawatt renewable sources. That is grid connected. Okay. So in that case, the biggest challenge is the floating solar substations. Have you heard about that? Floating systems. Really? That is what I am telling. So you think the amount yes, loading pattern. So now the thing is that related to the floating solar panels, the biggest problem for the floating panels is how to maintain the panels from the water contact. Because the problem with floating solar power plant is how to differentiate the panels from the water contact, because all the panels and all we are putting on the rivers and all. So how to maintain that isolation between the panels and the water? That is the second research area where you need to work on like some material science, or you can think of some nanotechnology where you can isolate these two. So that is another research area where you can focus. So this is just a small case study to analyze how to do the research and all. So it is related to the AT&C loss and the meter tampering, like smart meter tampering. Okay. I hope you all of you know how to tamper the meter, electrical meters. I hope everybody knows. Okay. Right. So
Earlier,
Now it is not possible.
okay. So I can tell you it is also possible.
then smart meters.
See, in India we have solution for everything. Smart, okay, how you are tampering the condenser meter? Any idea? Just close the door so that we can listen. We can discuss how you are tampering. Any idea like how to tamper?
Keeping some metal pieces
Magnets,
for coins.
with magnet
Coins
also,
needs
sir.
to keep and remember.
Don't stop that
So
discussion.
stations and
Reduce the
No,
resistance of the
that is related to some metal and all.
no, another view is they were disconnecting that only, that also they were doing it.
Okay. Apart from that one, say I don't want to touch the meter. Okay. Meter read, because if someone will come, if the logic means I will get cut. I don't want to touch the meter. Okay. Now bypass the meter.
That's what bypass.
Because if I tamper something in the meter, if somebody will come for investigation means I will be in trouble. Okay. Apart from that, there are some techniques how to tamper the meter. I will not touch the junction box, I will not touch the meter, nothing. Meter is as it is, very good boy, but I will tamper it. See, very easy task. You have sockets are there. You have one phase, one neutral. Okay. Meter will only rotate if the current will flow from phase to neutral. Or else meter will not rotate because it requires both front and series current. So there is meter will rotate. Independent will rotate. My question is, I take the phase wire. Okay, because I need to run the fan also, like as a fan. I take phase wire. I have ground. In my ground is there. Connect the ground to the supply to the fan will rotate, TV will work, everything will happen, meter will stop.
Yeah, basically.
Base and neutral, return path they are
Return path is out ground. Return path is not to
Now, in
ground.
spite of phase, we are connecting our devices to the neutral.
Neutral. It's a
Return
ground.
path is the counter.
Okay. So everything will happen, but meter is not stop. Completely. Meter will not rotate. Okay. But what is the problem here? You see the problem. Problem is very dangerous. Okay. No. Problem is, in power quality analysis, we have started something called earthing, okay, and something called lightning stroke. Suppose lightning stroke happen near to your home, somewhere. For lightning stroke also, return path will be the ground. Your device is already connected to the ground, so maybe you are not getting the
Low resistance path through that.
so you may get low resistance return path. Return path. So the device may damage. Okay. This technique holds good if your home is a single home. It is not a building. Like multi-story buildings are not there, because if it is a multi-story building, you are sending your current to the ground. Another person, maybe in the first floor or the ground floor, if he is having the device, the system, then the device will experience return current from your home to his device through the ground. So if he is something is there, when three things are used, then he may feel the shock. Okay? And sometimes if the earthing is not perfect, then heavy like blast will happen, because different resistance levels are there for earthing. I hope you know, like 0.5 you need to maintain, 0.7, 1.2, different structures. So that is how you can bypass the meter. In the same manner, smart meter can also be done. Meter will be there. Meter will not take any reading. Bypassing can be done. Okay, this is the techniques. Like
I think in the Karnataka they don't need 50% they have opted to use.
That's why, sir, in my case, meters are now
And after this,
it's not anything magic I can do in my home. Nothing will happen. Nothing will happen. It will work. Because say if you go to any substation, electrical substations, for them, because electrical substation also they need to pay the bills. Whatever power they are utilizing for the substation, they also need to pay the bill to the government. But they are doing bypassing like this. Or else how from where they will generate revenue to pay the bill to government. So this is the technique that you can also think of. But don't apply. Like it is danger also. It's danger also. Don't apply. For small appliances you can do. Not for air conditioner or all those things. So how to come up with some idea to tackle all these things? Because this is very high in MP. I hope there is no one here from MP or Gwalior. Okay. It is very high in Gwalior area. Okay. So how to have a device or something in the smart meter which can handle this one? Because meter is not sensing, but power is flowing. But how to handle this one? That is really a challenge. It is really an extreme level challenge. You put whatever you want. You cannot measure it till today.
So at UP also, they had a lot of problems with this. Tapping directly through line. That
We cannot, but how to think in terms of commercialization? So if you can come up with some device which can effectively attend this problem, then it will be huge investment for the entire country. Huge. Okay. Similarly, you might have heard some advertisement in TV or news channel or somewhere. Like people are coming up with one plug and play device that you need to simply plug it in the socket. It will reduce the electricity bill. Have you heard this one?
Yes, yes.
Okay, so what exactly this is? This is a simple capacitor. They are telling to put a capacitor in your socket so that power factor will get corrected and the amount will come down. But nowadays, to tackle that one, government has replaced everything with the LEDs. LED TV, LED this one, BLDC motor, everything is there. So now that problem is now not there in India. That power factor correction, now that problem is almost not there in India. Everywhere now, almost 0.87 onwards we are maintaining. Because about 0.87 according to the national level, it is now maintaining everywhere. Now, if that is the case, then why still in India the national power factor is below 0.7? If we are claiming it is 0.8 everywhere, then in India, why the national power factor is still below 0.7? Okay, the answer is the Indian Railway. Because whatever railway systems we have, we are using huge amount of induction motors everywhere. Where like every day, almost the power factor because of one train, it will come down below 0.4. To maintain that one, to again use the level of 0.7 or 0.8, you can find in railway tracks, particularly in every 25 kilometer, one small substation is there. In every 25 kilometer, near to the railway track only you will find a small spot. And full capacitor banks are there only to correct the power factors. Okay, that is there. We cannot compensate that one. So can you come up with some research, something where we can avoid that type of things? So that is the biggest research area now today. So for that one, if you search in Google or something, you will find one system now in the India is called Kavach. In railway particularly, now they are working on the technique called Kavach. It is still under research. It has not been implemented for India. Research is going on whether to implement or not. So you can think of in that direction. Okay. So these are the different
Coverage is for that
protection accidents as well as cover the power factor. So you can think of in that direction. So this is the one case study that you can take up for the research activity, and patent will automatically come from the research. If you are doing some good analysis, good research, patent will come automatically out of it. No need to think of or anything called patent. Now, second one is another biggest challenge is the scheduling, power system scheduling or day ahead forecasting. Okay. Now, if you see the day ahead forecasting according to the Indian DSCE scenario, we are talking about many things during our class to our students, like you can go for forecasting, this that will happen, smart grid will come into picture, all these things we are talking about. But practically whether it is possible in India, like smart meter concept or this type of grid scheduling, day ahead forecasting. Okay. Day ahead forecasting is something called spot market. I hope if you have handled this subject, spot market term you might have heard. Spot market means every day by 5 p.m. By 5 p.m. all the generating stations and discoms throughout the India, one national portal is there. There they have to enter the data. By 5 p.m. everybody has to log. After that, auto scheduling will happen, like from which generation system, how much power need to be drawn, the auto scheduling. It will happen and it will allocate. Like from this Karnataka state, today I will require this much amount of power for, let us say, Tamil Nadu. Or tomorrow, let us say, I require this much amount of power from Kerala or Karnataka. That is auto scheduling will happen. So every day at 5 p.m. they have to log. It is there also in India. But here in India, for everything we have another way. They have, idea is there, it is good idea, but they have told, okay, in a day, instead of one time, you can change your scheduling 16 times. 16 times. Like suppose let us say today by 10 p.m. or 10 a.m. I calculated, but for tomorrow, requirement is X megawatt for the entire Karnataka. Okay, but I have a deficit of, let us say, 20 megawatts. So I can approach Telangana or other states to supply that one. The bidirectional power flow is there, state to state is there. But suppose today 10 a.m. I have sent a mail to Ministry of Power like 16 or 20 megawatt extra is required. After 20 minutes, I can change that one. That means like this 16 times I can do per day related to the power schedule. Because of that one only, this power scheduling, like the calculation procedure is very critical. Because every time the constant is kept on changing, every time. It is not only for the Karnataka. For all the states, they have the full power, 16 times they can change their constant, 16 times. Because of that one only, it is taking lot of time, scheduling approach, okay. For scheduling approach and all, we have 3 data centers in India to do only power system scheduling, okay. One is itself inside the IIT Delhi. They have one company called Raining Power. I hope you heard Raining Power. The company is Raining Power, it is IIT incubated itself. So they have the supercomputer to decide all these things, and it is taking 3.5 hours to take a decision. That means by 5 p.m. to give all the inputs, by 8:30 or 9 o'clock, scheduling will come. For entire country, scheduling will come. Like from this state, this much power is required, from that state, that much power is required. Like this, scheduling will come. Okay? There are certain activities like military actions or defense strategy or all those things. For them, 30 to double scheduling is there. Like they can change 32 times in a day. So whenever that type of things is coming into picture, how to handle the situations. So you definitely need an optimization technique to do this one. So research can be taken up in that direction by thinking of the entire lesson. And whenever you are writing any proposal to any funding agency, you think about the nation. Okay, you should not write a project proposal for state specific. If you are doing that one, then people cannot take interest. If anything you are writing which is for the national interest, you work for health, you work for women safety, you work for energy, you work for something related to agriculture, then government will take interest. Or defense strategy, government will take interest. If you are writing something, some proposal which is not relevant to the national level, then government will not take interest in that proposal. Because why someone will invest 3 year time, some amount, something they will give. So they will not take interest. Second thing, for writing proposal, I am giving one tip to all of you. If you are writing any proposal, if possible, say this may work, this may not work, okay. If possible, you keep the PI as madam, anyone, okay. Gents, you must appoint as PI. Okay, I am not telling you always you appoint, you cannot give your credibility like this to anyone. But if you are doing in collaborative way, you can decide among yourself, keep ladies as the PI, principal investigators. Because government is like promoting that one, like more women power should come in the front to do this type of research, national interest research. So if that is the case are there, 40% chances are there your project will click in the first round. Say,
It's a fact, man.
it's a fact.
It's
Because government is encouraging.
Our
Our main objective is to get the project. Whether PA or co-PA, that is separate matter. Okay? But if you are really interested in a project, keep some madam as the PI and let with the co-PA, gents or ladies, whatever may be. But if you are submitting something, as much as possible, you try to give the credibility. Chances are there, it will hit. Okay? And I try to think something from defense point of view, because now defense is coming into picture everywhere, naval architecture, some like that, okay. So think in that direction, if you are getting something, it will really work, okay. Another thing I am giving you, don't think for big brands like DSCE or ANI. Small brands are there, very powerful brands, okay. Something is there, Indian Navy, okay. Its project approval center is in Kochi, project approval center. Every year, now in March or April it will come, call proposal will come, that is only for the OMI. OMI must be there in front, okay. So if you are a target for that one, that is only for Indian Navy research, naval-based research activities. If possible, because there will be thousands of problems, not thousands, hundreds of problem statements related to power electronics, related to mainly power electronics, very focused, like they require power system or shock architecture, something like that. You submit a proposal, chances are there it will get it. It will be. So think in that direction for project proposal submission kind of things, okay? So I think on this one I have discussed already. This is a retail architecture. This is real-time data from Indian preliminary website, not website, this is a yearbook they have taken. Can you look at identify what is the power congestion in this reform? Congestion is there, power congestion is there in the webbook. Two icons are there, power congestion is there. Can you able to identify what is the power congestion? This is one diagram, first diagram is at 1 p.m. 3rd August. Second diagram 1 p.m. August 24. Two different dates, same time. With same geographical coordinates they are captured. What is the power congestion? In the first figure, if you see here, one downward arrow mark is there. One little bit glitch is there, one downward arrow mark is there. That is the congestion we are facing. Like source is available to pump the power, but the load is not in a position to draw the power. That means whatever generation I am doing now is lost, completely lost, revenue loss. Clear? So can you come up with certain strategy where you can avoid this type of congestion? It is not just on that it happen. It is happening 24/7, every day it is happening. Every moment you open the website, definitely some congestion will be there somewhere, like this tick will come immediately because power is available but the load is not ready to draw the power. Basically, it is happening for Karnataka state. Because if you Karnataka and Himachal Pradesh, it will happen. Because in Himachal Pradesh, it is like in Himalaya region. Okay, so temperature will vary throughout the day. During the night time, people don't want power. But in Himalayas, because of the Gangas and all, there are almost as compared to other states, maximum hydro stations are there in Himachal Pradesh. So the power generation is very high. But we are not able to pump the power because load is not there. If load is not there, then we have to pump the power. Generation will happen 24/7, but pumping is not happening. So whatever generation we are doing is completely lost. Completely lost. Now, to avoid that one, India has power purchase agreement with Bangladesh, with Nepal, with Pakistan, with Bhutan. It was there. But now India is only doing power purchase agreement with two countries, one is Bhutan, one is Bangladesh. We are doing. Other three countries it stopped. Even we have some underground cables from Tamil Nadu to Sri Lanka. It was also there. But now that is also cut because Sri Lanka is in financial crisis, so we are not selling power to them now. That is also cut. So now at present we have only two international power transmission systems. One is in Nepal, one is in Bangladesh. Even Bhutan is also cut now, because now they have their own setup. So for that one, the problem is how to transmit the power from Himachal Pradesh to Bangladesh. It is a huge distance. Okay, so to transmit power from Himachal Pradesh to Bangladesh, I need to cross almost 7 states. Different states will come into picture. I need to cross 7 states to sell the power. And each cell, I hope you have heard the name for power grid. There is a difference between the power grid and your local transmission system. Here, like Karnataka State Electricity Board is there, so there is a difference between power grid and the Karnataka State Electricity Board. Every state has the board. The difference is there. Power grid does not have any generating stations. Power grid is only a facilitator. Facilitator means they will work only from state to state or region to region. Like this is the state, you have power, that is the state, they have power. I provide my infrastructure, you use the power by my infrastructure. And for that one, power unit, I will charge some money. That is the objective of power grid. Power grid is just a facilitator. I will create facility for you, you transmit the power, you process the power, or whatever power you are transmitting through my network, you have to pay to me. That is the work of the power grid. So through power grid, we are doing that one. But the problem is in India, power unit generation cost, power unit for hydro power plant, up to 2019, it was like 0.76 per unit generation cost. Now it has increased up to 1.1 per unit generation cost. But the selling power in Bangalore itself, it is we are getting at 9 rupees, almost 9.1 or something like that, we are getting the power. So why this much amount of gap is coming? Generation is 1.1 or 1.2, selling power is 9 rupees. So almost you can say 7.5 rupees is escalated. This is because of the AT&C cost, this is because of the power grid involvement, this is because of the state electricity involvement and all those things. Okay. So because of that only it has scaled up to a very high level. Okay. Can you come up with some types of technology or solution where I can reduce this one? Because this is national interest. Everybody is paying for unit 9 rupees or whatever maybe. If you can come up with certain things where you can reduce this one, definitely this is a good project. But you need to demonstrate that one before the committee, right? So this is the one power condition strategy. Now coming to the data sources in the power system. Data sources. 3 different sources I have stored. I have just take 10 minutes to wind up. 3 different data sets I have shown here. One is structured data, unstructured, non-structured data. Okay. 17 different data are coming to the system at a time. 17 different data are coming to the system at a time. But there is literally today also there is very less amount of electrical engineers who are interested in doing all these things because no one is trained in that direction. We are training our students with conventional power systems, conventional generators, motors, everything. But we are not training the students in that domain where now national interest is moving. So let us focus in that area and you start doing some small research or something. See, research is nothing about the publications, okay? Publications you can write something now, article, something it will get accepted, something it will get industry slope, something will happen. But that is not the research. Research is whether your research is really going to the market or not. That is the research driven articles. So if you see the research originally, whatever academic research we are doing in India, whether it is IIT or NIT, whatever may research, out of it only like 0.7 or even less than that is market oriented research. That is literally which will go to the market or technology level. That is happening. So there is a huge gap between the research and the marketability. Huge gap. Okay. So whenever you are doing any research or you are writing in a journal or something, take this national problem as the problem statement and you write a good research article for any journal, not like Stanford or not like other things, okay? Take that one as a statement and do some research, 100% you will get very good citations because if it is national interest and also that will act as a supporting document whenever you are approaching for any funding agency because funding agency will ask you what is the expertise the PI has. Okay, expertise in the sense what? Let us say your age is, let us say 50 years you are old. Let us say, whenever you are submitting proposal to any funding agency, they will ask for last 3-year publication. Even if you have 20 years of research experience, thousands of papers, its value is 0 when it is coming to research funding proposal. They will ask last 5 years you show the publication statistics. That does not conference. Conference they will not take any interest. Only journal it is categorical written. You cannot enter the conference paper also in the portal. Only journals automatically will fetch. From your proposal address it will fetch. It will take last 3 year journals. That too you must have journals in that research area. Suppose you are writing something related to agriculture. So you must have some research papers in agriculture to show, okay, I have expertise, then only they will take a call whether to give the project or not. Okay, so like this, So if you see the data science flow, I hope all of you know this one. So I am not explaining detail data science, how to deal with like anything. This is like something called computational optimization techniques. Okay, I will not tell much about this one. So like scatter, how to handle, how to do all this statistical analysis, RDC, any all those calculations. I hope you know. So I am not explaining in detail about that one. Last slide, this is one. You just have a look. This data I have taken from Clarivate. Clarivate is the research database. You see the research where it is looking from 2015 to 2024. Okay? The first one, if you see, traditional power system analysis, which was 40% in 2014, which is now reduced to only 13%. Okay, and where it has increased in the AI data driven methods. Where it was 8% in 2015, now 48% in 2024. If you see the research database in Scopus or anywhere, maximum data will get related to AI. Okay, but frankly speaking, it is a bubble. There is no relevance in the analysis when it comes to the hardware design. You cannot integrate any AI concept in the power system that to protection, where accuracy is very, very required. Okay, you are telling I do some regression analysis or I do forecast. It is not at all accepted when it comes to the power system. Because for forecasting also you require some 2 to 3 minutes. By that time, if your relay will not work, is gone. Okay. So that is the problem. Okay. So even if people are focusing more towards AI, you can think of AI as a technical tool to do your research in power systems. But try to do some core research in power system and power electronics. This AI analytics today it is there. After 3 to 4 years, it may not be there. Maybe it cannot be there. But if you are into power system, power instrument, it is evergreen. Always it is there. As long as this heart is there, power system will be there. Generator will be there, something will be there. So this is what I have discussed with all of you. So that's it from my side. And if your research is good enough, if it goes in, everything is in the right direction, finally you will get a call from the research funding agency, like the project has been shortlisted or the presentation on so and so date. If you can see, there also the application there. This is the mail that I received from AICT for my project of the shortlisted for presentation, solid is 2007. So if you see the expert review for, if your project is getting selected, review comments will come. That is very, very important. What is the comments they have given? So for me also they have given some comments. For me the strongest comment is the reason too. He has clearly written that it will make a commercialization. Commercialization is possible with the project what I have shown. So that is my strongest point. Already presentation is over. I am waiting for the result. So and some other comments also they have given. Like this, the validation will come. I have written something in my proposal like how you enter the computer system. They have given clear cut how about LoRa and 4G. Because government is now going for 5G communication system. Then why you are implementing 4G in your proposal? Because proposal was submitted 2 years back. At that time 4G and LoRa was there. So like that we defended. So if everything goes well, you will also get like this project mail from the funding agency to present your topic. Okay. So this is all about projects. You do some good work, definitely you will also get project in your life. 100% you will get. Only thing is what you need to work on any topic continuously in one topic for 2 years. That is major thing. Retention rate is very critical. Times will come like when all your paper is getting rejected and my college paper is getting accepted. AES is getting increment, I am not getting increment. But you don't think in that direction. You think for big achievement. Okay, see, once the project will get clear, definitely your institution will support you in terms of your salary or increment or anything. So, you work in that direction, definitely your project will get clear. Okay, I hope I addressed your points because see, whenever I discuss something with Indian faculty members or anything, my main intention is like at the end of the session, at least you should take some point from me, you implement in your concepts and try to get benefited out of it. If I come and I'll explain something very big things, because everything is available in Google or GPT, you can say there is no point of it. What is not available there, what is required for us, that is no one is discussing. So I thought of doing like this so that at least you can write some good proposals for your research also. Okay, and most important, the research is not related to any pressure from management or anything. Management will tell you do anything, you present rocket, tomorrow you launch it, everything they will tell you. But practically it is not at all possible. It is your personal motivation. If you want to do research, do it from your personal point of view. If you are not passionate about research, you do it. But at the end, I will tell one thing. If you do research, okay, the problem is your family will get suffered. Okay? The thing is that you cannot give time to them. Okay? Finally, and research is something, once you get inside that one, it will keep on increasing every day. Because we will keep on investigating, it will keep on increasing. Where to stop, there is no boundary. If you see any technique, where to stop, optimization and doing, where to stop, there is no boundary at all. Okay? So, it is your personal interest, but at least in your lifetime, 30 years of service period for everyone, at least in your lifetime, try to get only one funding agency or funding for your CV, which will really help you a lot in the future. Okay? So that's it from my side. Thank you all. If you have any questions.
First you told right sir, that you told that based on the previous data, future will be predicted. What type of data you would give to your system?
Sir, we are collecting 23 data in the sense from soil, start with soil. From soil I am collecting soil NPK parameters, nitrogen, potassium, phosphorus parameters. Then I am collecting temperature, what is soil temperature. Soil temperature means what is surface temperature, 1 mm distance, what is temperature, like that up to 7 mm and the root will go. Then I am calculating what is the level of solar light inside the soil. Inside the soil, the surface will be different, inside the soil, the root level, how much is there. What is the dryness factor on the soil. So these 9 parameters first I am capturing from soil itself. Then if you have seen the grape plant, it will require some support to grow and to come up to a stage. Okay? Height. So whenever it is taking that support, whether it is made up of wood or made up of steel, because if it is made up of wood, then infection chances is more. If it is made up of steel, water contamination will not be there, so infection chances is very less. Then how much dryness is there on the leaf. So for that one, 3 leaf sensors also we put on the leaf to identify leaf. Then small weather kit is installed there, which will continuously capturing the environmental parameters. Temperature is how much is there, BOD, COD concentration, what is there. Then what is the wind velocity, wind direction, which direction it is there. So like this 23 parameters I am capturing at a time. Based on the 23 parameters, exactly I have used one XGBoost regression analysis, only XGBoost is there, to do the forecasting. So based on that, it is doing forecasting. This is the what we get. So like this, you can not even a transformer also. Transformer also works like this exactly. So you put some sensors there, capture the data, develop some dashboard like this, show it to the government. If they are taking any interest, first you start with transformer, apply for an appointment with the Karnataka State Electricity Board, take appointment, you take appointment with the R&D, present there, very well present the everything, so that if they are taking interest, we will keep on later with support from the so like this.
Any other questions?
On behalf of the Department of EEE and the Organizing Committee of FDP, I would like to convey my sincere thanks to the resource person, Dr. Ritesh Das, for delivering such an insightful and engaging lecture on data science-driven smart grid energy systems. Your ability to connect cutting-edge research with real-world commercial applications made this session both informative and inspiring. The session greatly enriched our understanding and sparked meaningful discussion among the participants. We are grateful for the time and expertise you shared with us, and we look forward to applying the knowledge gained from your lecture in our academic and professional pursuits. Thank you, sir, for your valuable contribution. Now, I would like to invite the head of the department, Dr. Kumar, sir, to hand over the memento and the letter of appreciation to the resource person.
Thank you so much. That's usual, very nice content you have given. Thank you. Yeah, take one group photo. Thank you.